Go ahead and pause the video right now and do number 10. There you go. You should have gotten 0 and 2, and you should have checked both 0 and 2 to verify that they both make the original equation true. Well, let's look at number 11, and let's say we're not really paying attention, and we just randomly square both sides. On the left side, we would get 25, and on the right side, we would get, oops, I forgot to write the squaring right there. And when I have something a little bit more complicated, I just rewrite it. 15 minus 3n under the radical minus n. If we were to do that, we have a binomial over here, and this is where it gets really messy, but I'm actually showing you something you should not do. So I should have told you that in the beginning. Don't copy what I'm writing down right now. Please do not copy it down, just watch. Because I'm going to show you a different way to make it a lot easier. If you were to, though, square both sides, because that's what you've been doing all along, squaring both sides, you'd run into some trouble here. So this is where the trouble comes. When you do the first times the first, you'd get your 15 minus 3n. So far, so good. Then you would get minus n times the square root of 15 minus 3n when you multiply the outsides together. Then the insides together, minus n, again, radical 15 minus 3n. And then you get plus n squared. Well, notice by squaring both sides, you did nothing to get rid of the radicals, because when you combine those two like terms, you get negative 2n times the square root of 15 minus 3n. You still have a radical in your equation, and you don't want that. At all costs, try to avoid still having a radical in your equation after squaring both sides. Once in a while, you have to, but until you have no other option, you've got to try to explore a different way of doing the same problem. And this is where if you already did copy that down, you couldn't get rid of it. Let's just rewrite the problem, and let's see if we can figure out a different way. Well, there is a different way, and the different way is to see that when you add n to both sides, you end up getting negative 5 plus n, or you can write it as n minus 5 equals the square root of 15 minus 3n. So what we just did here is we isolated the square root symbol on one side of the equation and moved all the other stuff to the other side. Because squaring the other side, n minus 5, squaring that won't add a square root symbol in there, but squaring the right side will, and squaring the right side will remove the square root symbol. So then now squaring both sides, we won't still have a square root in our equation. So that's the little trick. So this is what you want to make sure you understand. Move the radical to one side, move all the other stuff to the other side, because then when you square both sides, n squared minus 10n, remember this is a binomial squared, so you're going to get 3 terms, plus 25. It's n minus, so let me do that over here. N minus 5 squared is n minus 5 times n minus 5, which when you do the FOIL method, n squared minus 5n minus 5n, so that's the outside and the inside, and then plus the last. All right, so then you combine these two terms to get negative 10n. So let's not lose sight of that part. And then when you square the right side, we get 15 minus 3n. Again, we have a quadratic equation, and quadratic equations, we know we want to gather all the terms to one side. So we're going to subtract 15 from both sides. We're also going to add 3n to both sides. And notice I lined up the terms that are alike. So lining up the terms that are alike helps me add these together properly. Negative 10n, positive 3n, that's negative 7n. 25 minus 15 is 10. Again, quadratic equation, gathering all the terms to one side. We have a trinomial, which means if it does factor, besides a GCF, which we have only a GCF of 1, besides that, it will only factor using the FOIL method. And we can see we have n minus 2 times n minus 5. So here, n equals 2, n equals 5. If we check 2 in the original equation, we get negative 5 equals, so the question is, does it equal the square root of, let's see if we can do this in our heads. 3 times 2 is 6. 15 minus 6 is 9. So we have the square root of 9. And then minus n, and we're trying 2 here, so minus 2. So does negative 5 equal 3 minus 2? Negative 5 does not equal 1. No. So n equals 2 would be what we now call, again, tried to call these before, they're extraneous solutions. It's an extraneous solution. So n equals 2 doesn't work. But let's try n equals 5. So let's put that right in here. N equals 5. Does n equals 5 work? Well, if you put the negative 5 on the left, that stays there. But if we put n equals 5, we get 3 times 5 is 15. 15 minus 15 is 0. And the square root of 0 is 0. So then minus n equals 5. So negative 5 equals negative 5, check. So therefore, n equals 5 is the only solution to that equation. I'm going to go ahead and have you do number 12 on your own, and I'd like you to actually answer that question on the Google form, and I will check the Google form. So I won't show you the solution to that right now. I will show you the solution when you get to class. So we're going to do numbers 13 and 14. In fact, that's what I'd like you to do. Do numbers 13 and 14 on your own. I'll show you the solution for 13 here in the next video, but I want you to submit your answers to numbers 12 and 14 on the Google form that I'll post on Canvas as well. All right, see you in the next video.